Welcome back to the part 2 of Amazon OpenSearch Crash Course. In part 1, we were checked how we can spin up the domain, how we can set up the domain. So we already set up this product search demo domain, OpenSearch domain with all this configuration. Apart from that, we already set up the product index. We added a different 5 or 6 product into our product index. We added a product documents in our product index. Also, we perform some basic search operation in the part 1. Now in part 2, we are going to make our product search much more powerful. We will cover full text search, exact matching, range query, filter, Boolean query, sorting, pagination, filtering, and some aggregation operation. So let's get started. So we already have created a domain and we already created our product index that we will utilize, and we will do further some more search operation and pagination and other stuff. So I'm connecting to CloudShell for doing operation on this product search domain, open search domain. So I already have this CloudShell open here. So next, what we will do is let us export our domain endpoints. So here we taken this endpoint and we are just exporting this as a variable. So we will do some commands. Here we exported in OpenSearch endpoint variable. We exported this OpenSearch or AWS OpenSearch endpoint, and now we will run through different commands. So I am using the same OpenSearch domain and product index from part 1, and now doing match query, right? Match query, we will do full text search. So let's start with the match query. Match is so let me run this query. So this is the match query we are running. So here we see we are given an open search endpoint, and then we have an index which is already exist, which having a for 5 products already product document already there. So this is the open search index. We are doing search operation, and we using pretty so with that get proper formatted JSON response header. We are passing this in body. We are passing query match, and then we are giving a name wireless headphone. So we already have this product, and here we are running match query. So match is a designated for full text search. So here we are searching the product name for wireless headphone. Open search analyze the search text and return relevant matching products. So let execute this. So here we get one match, right? So in hit value count we have one, and we return this wireless headphone product we get in the response. So this way we are able to do match query in the open search. So so that will do even if we run say for example, if we run wireless only here instead of entire wireless headphones, still we will get result. So because it will match a prefix, so it will do prefix based search, not a exact search in the match case, right? So here it match with the wireless in the prefix in name, so still that is why we get result, right? So match will do prefix based match as well, not required an entire exact match, right? Next we will do term query. So we will do term query after the match query. So here is the term query I am executing. So here we see this I am giving a same product index, and we are doing search operation, and in body we are passing term query term, and we already have a brand Apple present in our product document. So when we are running this term query is useful when we want to do a exact value match. So our in our brand field is a keyword fields, right? So whenever we want to do exact match, we are using term query, and term query we will do on keyword fields. So we can use term to find a product where the brand is exactly Apple, right? So so brand having a type keyword, and we are matching it with term. So in last query match case, we were having that data type was the text, and here we have data type of keyword for exact match term query, right? So here we get this result. because that brand is matching, right? So Apple is matching, so that is why we get the result. So if we execute partially, say for example, if we remove this, we will not get a result because it will do exact match. And we have a type of fields, brand type of fields is keyword type, right? And in match case, it type must be text type, right? So that way we have two different term query for exact match and match query for prefix based match. Next we will do filtering by categories. So if we do filter by categories, we can use the same approach to filter by category. So here we returning the laptop product. So let me do that query. So here we running term query on categories laptop. So here we get the result laptop. We have a total two value match, right? So we get that in the results. Or so next we will do a range query. So we can do a range query next. Here let me clear this and we can do a range query. In range query, it will do greater than and less than based match. So in range, we are doing range and on price greater than less than. So we will get the matching price in the results. So here we get total documents in the results which is having a matching range, right? So that way we are able to do price based filtering as well. So we filter product which is having a matching criteria between 100 and 1000, right? So a range query allow us to find a product within a specific product range between those. We are also able to do Boolean query as well. So let me show the example of Boolean query. So here we are doing Boolean query. We are doing query on our SAM index search operation, but we are doing Boolean query. So whenever, so we are doing term query on brand and as well as range query, right? So that is called a Boolean query, and we are getting here search results in the response for a particular matching product, right? So in this case, real product search usually have a multiple conditions. So for example, I might want Apple product that cost less than $1000. So this is where the Boolean query become useful, right? We can combine multiple condition into the one query here. So multiple condition we can combine into single query. Like in product e-commerce application, Apple, that Amazon and Flipkart having a lot of other filtering criteria, and they are doing filtering on millions of product with this kind of search criteria, right? So we are also able to do in stock based filtering as well. Like say for example, if we want to do in stock checking, so we can do query on. We already having a mapping field in stock, and we have a price range, right? So it will give a item which is having a price less than 1000 and it is available in the stock, right? So we get this in the result, which is matching like 899, that is less than 1000 and in stock is true, right? So that way we are low latency operation we are able to do. So we can add a more filtering here as well. We are finding a product that are in stock and cost less than 1000. So that this is much closer to real e-commerce search, right? So if we want to find a like Apple or Sony brand, then we can also able to do this kind of search as well. Let me run that another example. So here we are either one of the match, like either brand is Apple or a brand is Sony, and if any one match, minimum should match one, right? Any one match, then we are returning it. So Boolean query with minimum one match, either one match, then it will return, right? So here we have a brand Apple, so still we get in the result. So this way we are able to do that Boolean query. Also support pseudo operation, right? So this is a Boolean query pseudo operation. So we did here pseudo operation, either one of that match Apple or Sony. Then must not we are also able to do this must not operation. Let me run that query. So here we have a query, then Boolean must not, right? So whenever brand not Apple, that will result in the here we get brand Dell, Sony and other, but we did not get Apple because we use that must not query. So we are able to Boolean must not query as well. We are able to do an open search. Then we have a sorting operation, like we are able to do some sorting operation as well on our open search index data. So when we are running search query on our index product index, we are doing query match all, and then we are sorting it price ascending, right? So here we get a ascending price wise, so whatever the lowest price it come first, then here we see, right, price is 199, then pricing 249, and then price is 1299, right? So that way we are able to do sorting operation. uh, Same way we are able to do pagination as well, like in RDS we are doing limit and offset, right? In select star from table name, where condition, and then we do some limit and offset. So similar way we are able to do pagination as well while we do the search. Like here we have product index, we are doing search operation. In body we are passing from and size, so it will get a data from 0 and size a 2 record in the result. So here we get a 2 record in the result, and it was offset was start from 0, right? So here we get a 2 record, total 2 product in the response. So this way we are able to do pagination as well. So that will return a data of first page when we pass from 0. So if we can pass from 2, then it will give us a another page data, right? So it will be different data than the first one. So here we get this data id 1. Previously we will get different data in the result when we did that, right? So this way we are able to do this way we are able to do operation on pagination base as well, from and size parameter. uh, so generally we don't want to return a thousands of product in single response. That's why OpenSearch support the pagination from, like where we want to start and all, right? Same way source filtering also we are able to do. Let us run that example. So here we have a if you want to get only specific fields from that, so here we get all the records, but we get only specific field which we specified in the source, right, in the body request. So name, price and rating only we get in the response. Here you see name, pricing and rating only we get in the response for all the product. So all product are exist currently in our product index. In RDS we have a table, but here we have an index, right? Uh, so we can also control which fields are returned in the results. Also we are able to do multi-match operation. So if you want to do multi-match operation, we can do that as well. So very powerful open search in terms of searching, low latency based search. So here we have a multi-match query where we have a different field we given, right? So what we are doing is query Apple, and we are matching in any of these fields. So we get this record which is matching at any one place, right? So sometimes user don't know exactly which field contain that they are looking for. With multi-match we can search across multiple fields. Here we are so here we are able to search Apple within a name, brand and category. So we are able to search that in three different places, right? So real world product search, this is the so if we do a real world product search, it will have a bigger search query. So these are few demo, right? But when we do real time operation in our application, there are complex query as well. So here now we are doing real time product search. So here we are doing product search operation on product index. We return this uh, body, right? So now let's put everything together in this query. And here imagine user search for a laptop. and we want only product that are in stock, cost less than or equal to 1500. Yeah, so cost less than equal to 1,500 dollars, and we want to highest rating product first. So this single query combine full text search, filtering, range condition, sorting, and pagination. This is much closer to what we would use in our real product search application, right? So here you see we are using here the must query that will match the laptop, and then we have the filtering in stock, then price is less than 1500, and we have a sorting, rating, descending, so we have a proper sorting, right, and size 10, so we are only returning 10 product. So this way we are able to combine multiple operations, like we only have a product that is in stock less than 1500 price, and highest rated product. So this is kind of closer, we are generally using in e-commerce, like Amazon or Flipkart, which having a millions of product. In this kind of application we get this kind of search, right? So here we search that and we get this response in the result, right? Overall. So now we can run one more query, which is aggregation by product category. So let us run that. Here we are doing aggregate query, and we are doing based on categories, fields category. So this is we get a aggregate query, right? So when we do aggregated, OpenSearch is not only a search engine; it can also perform analytics using aggregation. For example, we can ask OpenSearch how many product we have in each category, right? So here we see in a headphone we have a two count, in laptop we have two count. So this kind of aggregate operation also we are able to do in OpenSearch. Similar way, if we want to do aggregation by product brand, we are also able to do. So whenever having a millions of product in Amazon or Flipkart kind of application, you can imagine how fast this open search is, right? So here we did the aggregation operation on brand fields. So here we get brand wise, Apple having a two product, Dell having a one product, and Sony having a one product, right? So this way we are able to do brand wise aggregation. Also we are able to do average product price as well. So there are strong aggregation function also available in open search apart from powerful search. So here we are doing average price operation on fields, right? So we can also calculate the metrics. For example, we are calculating the average product price here. So average product price is this based on that price fields. Same way, like search and aggregation operation, we are able to combine in open search if we want to do both the operation together. So here is the example of search. We are doing brand searching on brand as well as aggregation operation, right? So we are doing headphone one and laptop one. So in this case, we can combine search with analytics. So here we are searching for Apple product, and at the same time getting a breakdown of those product by categories, right? Searching by Apple, and then we are doing aggregation operation. So this way we are able to do different powerful search analytics operation on open search. So now we have a much more realistic product search system. We covered a full text search with match, exact matching, term range query, Boolean query, filter, sorting, pagination, multi-field search, and aggregation as well. But there is still an important things, like in real application we don't want to build a large JSON query manually inside our application code every time. So that's where OpenSearch template become useful. So when we do a production kind of application, we are defining our own search template, and that some search template we are using in our code, right? So that way we are able to do powerful operation when we define a search template in our system. So in future part, if you want put a comment, then I will work on that future part. We will do some advanced steps. We will create a reusable search template using must mustache, pass dynamic parameter, and build more production style of product search API with powerful search template defining and use it. So hope you get something out of this. Thank you for watching. Please don't forget to subscribe.